So this week we're going to talk about penguins. We've got data on the body mass of various penguins, and body mass is going to be our response variable. We've also got a bunch of other predictor variables measured on these penguins. One of the most important ones is going to be species. So we've got 3 different species. There's chinstrap, gentoo, and Adelie. I don't actually know how to pronounce it. I did poorly in French class and it has an accent on it, so it scares me. But we've also got things like what island that they live on. We have some measure of the food that they ate through the isotopes in their food. So I don't actually know how they measured it, but they know the isotope abundance of carbon and nitrogen in their bodies, and that's reported. And that gives us some measure of location for these penguins, or it could be just how much they eat as well. We've got things like how big their clutch was, which is how many eggs they laid, or how many eggs their partner laid. We have their biological sex. We have the length of their flippers. We have the size of their bills, and these sorts of things. And we're going to use all of these to try and predict the body mass of these penguins. And so we're going to go through in detail a regression to show you some of the steps that we take, a lot of the model building that goes into fitting these things, the visualizations that inform the model building, and the results that we get from this. So the results often make it into papers, and you get to see, you just randomly see in brackets, it was statistically significant, p equals whatever, or p less than 0.001, or something like that. What you don't see in papers, even if you've seen linear regressions in published papers many times before, you don't see their visualizations that they used to fit those models. You don't see the models that they tried and didn't work. You don't see some of the summaries that they did of their data to make sure that they were doing the right thing. And so that's what we're trying to give you this week. So instead of having things like PowerPoints this week, it's actually organized into 3 documents. So we've got the visualization, just looking at the data in different ways. We've got a modeling document, and we've also got the communication, how we would actually communicate these results. There are also 2 other lectures that are less important. They're still there. They're still things you should know, but they're more advanced topics. One of them is on nonlinear models, so how we can extend this linear modeling framework to things that aren't actually linear. The other one is on polynomial regression, which is kind of in the same vein. It's not linear, but it's fit with a linear model. Essentially, it's interactions with itself. It is technically linear, it just doesn't fit into the paradigm that many people would know about. So this is kind of the culmination of everything. All of the things that you've learned so far are going to come into play here. This should serve as a nice review. The data set is publicly available, so I give a link to it in the first, the visualization document. You can download it yourself. If you use R or Python, there's actually packages and libraries that have this data in it, so you don't even have to download anything yourself. Just install the packages. If you're on some other program, you can use whatever you choose to, and you'll have access to this data. So happy modeling and have fun.